Okay, you're watching this video because we didn't quite get to 32 and 33 in class. So here we go. Question: what is the total distance that the Zamboni covers over the first 10 seconds? Well, you gotta ask yourself, what do we want? We want total distance, but we want total distance in the interval of 0 to 10 seconds. So how do we get that from the graph? Well, you ask yourself, how do you get from the graph? Well, is it a direct read? No. If you open your eyes and look at a velocity versus time graph, you see velocity and time. That's not the one. Is it a slope? Well, slope would be velocity over time. We just did that 8 times for acceleration. So that's not it. Is it area? Area would be velocity multiplied time. And if you rearrange this little equation on PRT6, velocity times time does give you d. So yes, we are actually going to do area. So you actually now have to go back to the graph and do area. It's a distance versus time, or a distance rather we're looking for. So distance is a scalar. It would be nice to pull that off the scalar speed versus time graph, which we can do. So the first 10 seconds, 2, 4, 6, 8, 10 goes to here. So we need this area plus this area. That is our full area from 0 through 10 seconds. Now, how do we actually do that? You could go back and do trapezoid formula for both, but most of you will say, well, there's a rectangle, and here's a triangle, and then, here's a little triangle, and another little triangle, and color those in a little better, and there's a rectangle in between. So, if we're going to do it the long way, we have to do this rectangle plus this triangle plus this triangle plus this rectangle plus this triangle. And none of those are particularly difficult to do. Notice that the base of the first rectangle is 2 seconds and the height is 1 meter per second. So the first part is 2 seconds base times 1 meter per second height. That's the first one. Then we have a triangle. A triangle has a base of 2 and a height of 1. But a triangle is 1/2 base times height. So plus 1/2 times 2 second base, height of 1 meter per second, plus this little blue triangle has a base of 2 seconds and a height of 1/2 meter per second. That's a triangle, so 1/2 base, 2 seconds, times height, 1/2 meter per second, plus the rectangle, which is 2 seconds by 1/2 meter per second, and then that last triangle, which is going to be the same as this little triangle, another 2 by 1 as a triangle, or 2 by 1/2, sorry, as a triangle. So we're going to run out of room a little bit here. So that little rectangle was a base of 2 seconds times a height of 1/2 meter per second. Finally, plus that little triangle on the end, 1/2 base of 2 seconds times height 1/2 meter per second. Let's put all this together. What a mess, right? That's not so bad. First off, they're all seconds times meter per second, which means all the seconds cancel and leave you in units of meters, which is a distance, so that makes sense. 2 times 1 is 2, plus 2 times 1 is 2, half of that is 1, plus 2 times half is 1, half of that is 0.5, plus this one here, 2 times half is 1, plus 2 times half is 1, half of that is 0.5. That gives you a grand total of 2 plus 1 is 3, 3.5, 4.5, 5 whole meters. Fantastic. Now, just in case, could you have done this from the velocity versus time graph? And the answer is yes. You would have first found this area up here, and you would have then found, 10 seconds is here, this area down here. And notice one of these is a positive area and one of these is a negative area. For a distance, we don't care. We just call them both positive and add them up. This is the first two terms from our math. This is the 2 and the 1. And then this down here are the last three terms, which are the half, the 1, and the half. So you would just add them all together. Now, does that positive and negative stuff ever matter? Well, yes, it does. Because you might be asked about the total displacement after 10 seconds. Now, let's deal with that first part. Not the distance, but the displacement. When we say after 10 seconds, we mean from 0 to 10. So at the 10-second mark. Displacement is also an area. It's specifically, though, since it's displacement, it has to be an area from the velocity versus time graph, not the speed versus time. And in fact, let me change the color down here. What you'll end up doing is you'll take the positive area and you will subtract the negative area. So, you figure out the area of this part above. The x-axis is always our point of reference. The area above, and since we already did the math on this, we don't really need to redo it. Here, this one and this one gave us a 2 plus 1, a 3 meter displacement, and that was a positive. These three were actually below the axis, so they actually will get a 0.5 plus 1 plus 0.5 is 2. They actually will get a negative 2 meters. This is positive, we called east. This is 3 meters east. And negative, we call west. This is 2 meters west. You put these two together, and what you end up with is a displacement of 1 meter, and it's positive, so it's east. What about after 20 seconds? Well, the displacement from 0 to 20 is, we already know 0 to 10 is 1 meter east. And then 20 ends right here. So we also have to get this big Chabunka area. Is it annoying? Maybe a little bit, but you can do it. We have a triangle right here, and then look at this mess. We have a nice big rectangle in the middle. Let's make that. And then we have a little rectangle over here. And finally, we have a little triangle over here. So it might be easier actually to write them out right here, just to get our numbers down instead of flipping back and forth. This, by the way, is all positive. So from what we did on the page 11, this piece was positive 3 meters. This piece was negative 2 meters. So what's this piece? Well, let's do it. This little segment is 1/2 base is 2 seconds, height is 1.5. So 1/2, 2 times 1.5, that one comes out to 1.5. Let's do that red region in the middle. The red is just base times height. The base is 246 seconds by 1.5. 6 by 1.5, which comes out to 9. This little blue rectangle is a base of 2 times a height of 0.5. That comes out to 1. And then this triangle over here is a 1/2, the triangle, base of 2. The height now is only 1, not 1.5. After 2, this comes out to 1. So if we combine these four, what you get is 1.5 plus 1 plus 1 plus 9. And that gives you, that's 4.5, right? Or no, sorry, 3.5 plus 9, which gives you a grand total of 12.5 meters positive for this segment. And so then if we put them all together, we had our plus 3 meters, minus 2 meters, plus 12.5 meters, comes out to 13.5 meters positive, which means 13.5 meters east. And so, to get distance, you do all of the areas to the x-axis, whether they're above or below, call them all positive and just add them up. For displacement, you do the same areas, except above the axis is positive, below the axis is negative. And so they actually subtract from each other if they are both above and below, and there's your answer. Good. What new physical quantity did V versus T Dr. Sarf reveal? The new one was acceleration.